Here in Chapter 2, we're going to take a look at kinds of reasoning and deductive reasoning. We will talk about inductive reasoning too, because you can't talk about uh, deductive reasoning without kind of comparing it to inductive reasoning, but we're going to focus on the deductive reasoning in this chapter. So what we're going to try to accomplish in this lecture is to distinguish between deductive and inductive reasoning, recognize assumptions and show how they affect conclusions. We'll look at using deductive reasoning to make predictions, and then recognizing some common thinking errors and psychological misconceptions. So we'll jump into the kind of the nitty-gritty of the two different styles of reasoning, talk about conditional reasoning, and then we'll get into the errors that come as a result of those things. So what do you think? Can I be certain about a conclusion I draw, or is there always some uncertainty? We like to overemphasize how much we know about something and overestimate our certainty of an idea that we have. We might assign a certain percentage of likelihood that something happens. We don't do it like consciously, but in our heads, we kind of like unconsciously think, oh, well, I know this, and maybe like 80%. Or I'm not really so sure. Maybe I only know it about 30%, so I'm not really going to go out on a limb for this thing that I say that I know. But what happens is that we do have thinking errors sometimes, like a black and white thinking error, where we will assume that we either know something completely or don't know it at all, and there is no gray area. And we'll talk throughout this course about how the gray area is where most people have a sense of knowledge of something. That's the place where you have to make decisions and think and all those things that are taxing to our brains, so we tend to stay away from them. Right? Does improving the self-esteem of students improve their grades and test scores? Well, that sounds like an if-then statement. Okay? If people have better self-esteem, then they will have better grades and test scores. So is that the case? Could that be the case? Okay. Does blowing off steam or venting anger help reduce it and prevent aggression? Some people say that if you have an outlet for anger, it will decrease the likelihood that you act on that anger. Some people don't. So what is the conclusion that we have on that? Is profiling of suspects effective in identifying perpetrators? Right? So if somebody has a particular look, will it mean that they are more likely to commit a crime, for example? So there's some things to think about, some ideas to keep in mind as we go through this, and maybe you can go back and revisit these as we keep going. So let's jump into the kinds of reasoning. There are two basic types of reasoning. We have inductive reasoning or induction, or deductive reasoning or deduction. Okay. So when you watch a movie with usually a spy or like a Sherlock Holmes movie, they tend to use deductive reasoning, and we'll talk about what that is. But people talk about, I did do something, but you don't ever hear people saying, well, I didn't do something. So deduction is what most people are familiar with. So if you understand that sometimes we have ideas about the world and then we try to go about proving them with specific examples, then you already know deductive reasoning to a certain extent. Okay? But we do need to know the difference between these so that we can learn how to better use information, especially for research, but better use information to draw conclusions, okay? Especially when conclusions have a certain level of uncertainty. So inductive reasoning is when we use specific information, specific examples, and then we draw conclusions about a larger group of people. An easy example of this is if I have a class and everybody in the class does really well on an exam, then I might induce that people would do well who are outside of that class too. So I could say something like, people in this class did well, so that means that people in general would also do well in this exam. Or if I wanted to extend it to a general principle, I could say something about the nature of the test. If some people do well on it, then the test must be easy. So I could increase my knowledge or increase the scope of the information about the test. So if you want to think about inductive is increasing, that means that we go from a specific example and increase the amount of examples that it applies to. So we go from we go from a specific to a general bit of evidence to form the conclusion that we have. Okay. Another example, scientists generalize from many cases or research results to justify some theory or hypothesis as true, which is very interesting because probably 100 years ago, 150 years ago, when psychological theories were starting to develop, most of the time people were just kind of like generally coming up with theories, and they would say, I have this theory, and then other people would say, well, what are the bits of evidence that support it? And they say, well, I'm not so sure. So we were kind of doing deductive theory development all the time 100, 150 years ago. But in some cases in psychological theories, there are cases where like Piaget, he came up with a theory that's based on the development of his children only. So like four kids. He had some kids, and he developed a theory based on only a very small amount of samples. So he technically used inductive reasoning in that case, but it was based on such a small amount of people that's really not a valid way to do it. So we kind of had this shift that happened about 150 years ago where people started to go from complete deductive reasoning, then they started doing inductive reasoning, even though it wasn't always appropriate. And then inductive reasoning has kind of been the trend going forward, where we start with a specific amount of observations and we generalize things. That's not to say that we don't use theory, it's just that we typically rely on research results, which tend to be small samples of people, and then we make general conclusions based on that. So when you get into a class like Research Methods in Design, we'll talk about generalization a lot, meaning how can we take the results from our observations and increase them or use inductive reasoning to make conclusions about a greater population. So here's a critical example of inductive reasoning, and you may have heard of Broca's area, especially if you've taken psych classes in high school, maybe AP Psych, or if you have a transfer course in psychology, maybe you've heard of the Broca's area. And Pierre-Paul Broca, he came up with an idea about a specific part of the brain that is designed to interpret language and articulate it. And what would happen with people who have Broca's area deficiencies or Broca's area trauma would be that they would try to speak, but they wouldn't have fluid speech. They would just talk, but every so often they'd try to find a word, it wouldn't come out right. They'd kind of be aware of it. They would stammer, and they would kind of start and stop because they're trying to think of what to say, but they know that their mouth isn't formulating the right thing. So in that case, people are aware that they have an issue and they can't articulate a word, so they kind of stop themselves from doing it. Which, by the way, is different from Wernicke's aphasia, where people talk and talk and talk, and whatever comes out of their mouth, they don't recognize that it's wrong, so it sounds like word salad. So there's just an issue where they cannot recognize that they're saying something that's incorrect. They don't have this feedback loop. And all of a sudden they talk and it doesn't make a lot of sense to the hearer. So with Broca's area, this is a little bit different. So with Broca's area, he recognized that there was somebody, and the case is called tan because when he tried to speak, the only words that he could really get out were the words tan. He was aware of it, that he was saying the word tan only. It frustrated him, but that's all he could formulate. So what happened was that Broca thought, oh, he has an issue with this part of the brain that's in the left frontal lobe, near the motor cortex too, which is interesting because it is a motor issue. And what happens is people don't speak well when they have trauma to this, or at least Tan didn't. So his idea was, could we take this example of Tan and could we find other people who also have this trauma and come up with some kind of theory that describes what is happening to them? Okay. So he did this, he increased the amount of samples that he could find, and then he came up with a theory based on that. So he started with one specific observation and increased the number of observations, and then he used this inductive reasoning to come up with a theory that says that you can have Broca's aphasia, which, if you find something, you can name it whatever you want to. But you have this Broca's aphasia, and if you have Broca's aphasia, then you can expect to have speech impairment. Okay. Now, Comparing that to deductive reasoning is when we have this kind of general principle and we try to find specific examples that support it. So it's kind of like you make an assertion, then you go back and you find the support for it, which is not a bad way to do research. Sometimes we want to find a theory and to kind of see if it checks out. So a lot of times we'll start with a general idea and see if that general idea carries any weight. Lots of times we call this fact checking. So if you have an example where somebody makes an assertion, like if you're watching the news, and if you're watching the news, you've got to find something else to do, man. That's just depressing to watch news all the time because it's not a fun thing to do. If you're watching the news, then you will see that people make all sorts of claims, and then what happens is somebody goes and fact checks them to see if what they're saying is generally true or not. That's more deductive reasoning. Okay. So what happens in the case of Broca's theory is that if you wanted to make a prediction about somebody who has some kind of a speech impairment, you would start with the theory, and then you say, okay, what's going on here is that we have this Broca's aphasia, and if somebody has the speech impairment, then they have Broca's aphasia. So when you think of that, you have to kind of understand that somebody went and did the work that said, okay, here are the specific examples about Broca's aphasia, and then you create a theory. And now we have the benefit of saying, oh, here's a theory. If people have some kind of speech impairment, then it's probably Broca's aphasia. It's because we have this theory. We can go back and see specific examples that look like it and check it against the original theory to see if it makes sense. I know that it kind of seems a little bit circular, but that is the nature of deductive reasoning and inductive reasoning, is that they flow back and forth toward each other. Okay. We'll look at an example that can clarify this, and we'll put some specific terms to it as well. Okay. So when we have deductive reasoning, it becomes very important. Some people think, well, inductive reasoning is better because we're taking our original observations, we're building a case for it and coming up with a theory. That's true, but deductive reasoning is important because now once we have this foundation of information, we can use it to make predictions about the outcomes of something that we're trying to explore. Okay. We can also go from a definition to an example. So again, if we stick with the Broca's thing, by definition, if somebody has a hard time articulating words and they're aware of it and they stammer because of it, then by definition, we wonder if that specific person has Broca's aphasia. Okay. That works with any kind of diagnostics, by the way. So if somebody has the traditional characteristics of some kind of mental health disorder, then you go and you check that specific case to see if all of the criteria follow, and if they do, then you've deduced that that person has a specific mental health disorder. Okay. Another example of that, let's say you're in criminal justice, law enforcement, or if you're working as like a pre-law student, you would be looking at a law that governs the way that we're supposed to behave and things that are legal and not legal. We'd look at a law and then see if a specific case, a specific individual is following the law or not. Judges will use deductive reasoning. They'll use this big theory about the law and they will apply it to an individual to see if that individual is obeying the law or not based on the facts of the case. So you take the general theory and then you support the observation based on that theory. Sometimes you'll hear deductive reasoning called working from a theoretical perspective, meaning do I have this basic understanding of something and can I use that basic understanding of something to explain what is happening on a smaller scale for a specific individual case. So hopefully you've kind of heard this language being used precisely enough to where you can see the flow of deductive to inductive reasoning. Okay. Here's an example of some of inductive versus deductive reasoning. Okay. Let's say you have three people, and again, we're kind of staying with this Broca's aphasia example. Okay. And on the left side of the screen, you see that there's an inductive reasoning tract, meaning we have these three brains. We have Tan, Rodney, and Sarah. So we have specific examples, and we are trying to increase the number of examples that look the same so that we can support the theory. So if in all those cases you have some kind of speech impairment in that Broca's area, speech impairment, and there is some kind of damage or trauma to that Broca's area, then the conclusion is that the damage to that area impairs the speech production. So that means that we can support the generalization of Broca's theory. If not, then we can rule that out. And then we have deductive reasoning, where we start with a theory that if somebody has damage to the brain, then the speech production will be impaired. Okay. So then we say, okay, if we have this working theory and then Bill has damage in the Broca's area, then we conclude that his speech will be impaired. So we work from the general theory to the effect, for example, damage to Broca's area, and then conclude that he will have speech impairment. Okay. So we work from the theory down to the observation when we are working with deductive reasoning. And inductive reasoning, we're working with the observation and then building toward the theory, which is part of the conclusion. Now that we've taken a look at the difference between deductive and inductive reasoning, let's take a look at conditional deductive arguments. And like a lot of other things in psychology, sometimes we give fancy names to things that we're kind of aware of already, but it's a good idea to formalize these ideas so that we can use them more precisely. So a conditional argument is just an if-then statement. If-then statements are usually based on what's called a major premise. So a major premise is some kind of theory that we know about. In the example that we've been using this chapter with the Broca's area impairment, the general theory is that if there is an impairment to that area, then it will lead to some kind of speech production issue. Okay? So the major premise is that damage to the Broca's area leads to some kind of speech impediment or impairment, and we can then go on to create this minor premise. Okay, so if the major premise is the part of the theory that suggests what will happen, then we can look at smaller bits of evidence about that by using an if-then statement. And there's a little bit of terminology to go along with that. So we know that Broca's area damage causes a speech impairment, so we can say that if somebody has damage to the Broca's area, then they will have speech impairment. So it's a very simple thing. So we have a general theory about the Broca's area and the damage to it. Then we have a specific example. If somebody gets hit in the head in the area directly above the Broca's area, then they will have some kind of speech impairment. So again, a little bit more terminology. The major premise is the overall theory. The minor premise is what we are testing or what we're looking at specifically for an example. So the minor premise in this case is that John got into an accident where he had blunt force trauma to the area directly above the Broca's area. Then the conclusion will be that he has some kind of speech impairment. Okay? So you can see that there's this kind of this fine-tuning of the argument that happens when you go from a major premise or a theory down to specific examples. And when you think about these antecedent and consequent relationships, there is some kind of validity to it. Things have to happen in an order, and they have to be the premises have to be true, and they have to lead to some kind of conclusion. So let's say that Bill had already had, or John, I think my example was, John already had a speech impairment, and then he got into an accident. Well, okay, there is some kind of connection between the area of the brain that was damaged during the accident and the speech impairment, but the speech impairment was present first, so we might not think that it has to do with the Broca's area. If it does, it wasn't because of the accident. So there has to be some kind of temporal relationship between the if and the then statement. And you'd be very surprised in life how often people don't consider that when they're making an argument. They don't consider that something happened before or after the thing that they're claiming was the result of it. So we have to make sure that we go in order that these conclusions occur after the antecedent. The word antecedent means to place before. So it comes before the conclusion. So we need to make sure that the thing that we are claiming leads to our conclusion actually happens before the conclusion. I know when we talk about it, it sounds like, well, yeah, of course that's the case. But when we're making arguments, we'll oftentimes flout that rule in order to make a point, which is not good arguing. Okay. So again, the argument must follow the correct logical form to be valid, and all the premises must be true for the conclusion to be true, or at least for the conclusion to be adequately related to the antecedent that we are claiming. So how do we make a sound deductive argument? Well, one of the things that we have to consider about a deductive argument is what we're trying to do. If we are trying to confirm some kind of theory, then we are making a deductive argument. So if we're taking a broad idea and trying to find bits of evidence that support it, we're making a deductive argument. Okay? So here's how we do this. If we want to have a sound argument, you have to assert the antecedent, meaning that you have to suggest something about the nature of the conclusion that you're trying to make. Okay. And in table 2.1 in the book, there's a good example of how we assert the antecedent with the Broca's area, the example we've been kind of hanging on now for the better part of this lecture. And we have to assert that there is some kind of damage to the area of the brain that would lead to the consequent. Okay, so we've kind of talked about that. We know what we're talking about. So we have a valid argument if that's the case. And again, it looks like this. So you have to have some kind of relationship between the antecedent and the consequence. Okay. Now, some other examples of this, or any kind of theory that you have, so like social learning theory. So if we talk about like negative behavior that people have, and the theory goes that if people see, let's say, negative behavior, they're likely to replicate that negative behavior, especially with kids. So if we have that major premise that there's this theory that says that people will use vicarious observation in order to learn how to do things, and I think one of the best examples of that is probably Bobo the Clown example from social learning theory. It's a Bandura thing. And what happens there is that a little boy sees somebody playing with a doll or a blow up clown, rather aggressively, violently, pushing it, hitting it, kicking it, things like that. And then the child does the same thing. So the major premise again there is that if we have social learning theory that says that watching something happen will lead to another person to do that thing, the minor premise would be a little boy watches a man kick a doll, and then the consequent is that the little boy will then go in and kick the doll. All right. So if that's the case, then we have sound deductive reasoning because we've gone from the major premise, the overall theory, through the minor premise, the antecedent, affirming the consequent. Okay. So we've asserted an antecedent and affirmed the consequence. Now, what's kind of cool about this is that we can now use deductive reasoning in order to make predictions, which is where a lot of research comes from, by the way. If we're trying to do some research, usually what we're trying to do is create a prediction. Lots of times it's in the form of a hypothesis in order to make conclusions. I use conclusions in air quotes, I think, because sometimes our conclusions are based on other things, but we can make conclusions about our research based on how well we tested our hypotheses. But we're still generally moving from an overall general statement of what we think is true about something and confirming that with predictions. And in that way, it's rather confirmatory, where we're trying to confirm something using deductive reasoning, as opposed to inductive reasoning, where it would be creating this theory that we're using. Okay. So we can use conditional deductive reasoning in order to make scientific predictions from a theory. As a matter of fact, that's what a lot of hypothesis testing is. We don't use if-then statements in hypothesis testing, but the nature of the relationship between the things that we're testing is still present as if it's an if-then statement. We're still talking about an antecedent and a consequence. So if we're making a prediction, we'll say something like, does the age and amount of cigarettes that somebody smokes predict the amount of heart complications they're going to have? Right? So we're kind of using that hypothesis type statement, but really what we're saying is if somebody is above 50 years old and smokes a pack a day of cigarettes, then they're going to have more complications with their hearts, right? So we can deduce some kind of relationship between variables like age and the amount of cigarettes that you smoke in order to predict the amount of heart complications that they're going to have. So again, there's some kind of suggestion that we're still following the conditional deductive reasoning format with the antecedent and the consequent, maybe drawing on this major premise that age and smoking leads to heart conditions, and then drawing a finer point by looking at specific examples of it to support it. Okay. So again, we'll look at social learning theory as a way to look at this. So reminder that social learning theory, this major premise is that when people observe another person, then they're likely to engage in that behavior. And again, we're looking at the Bobo the doll experiment. So the method that they had, if we're going to look at this more scientifically than just me explaining it at the top of this topic, you have Albert Bandura and, forgive me, I forget the first name of Walters. It escapes me. The method was that a group of preschool children who were observed an adult behaving aggressively toward a Bobo doll, and the second group observed adult in the room not behaving aggressively. The finding was that when people saw the man behaving aggressively, then they would behave aggressively as well toward the doll. And here's a fun little thing from the experiment. Okay. So you can see that that if the adult, in this case there was a female model who was misbehaving, who was being aggressive toward the doll, and then all of a sudden you see the kid being aggressive toward the doll just the same, and look at that, it was the same between boys and girls. So maybe there's some more theory that's based on that. Okay. So we made a deduction in this case. We went from social learning down to the specific example. If a group of children observes the behavior of an adult that's aggressive toward Bobo doll, and another group does not, then you will see a difference in the behavior. Okay, so the then statement then is the group observing the aggressive model will be more likely to engage in aggressive behavior than the control group. And again, we're looking at this example. I think we've talked about deductive reasoning examples like 15 times already this lecture, but it is important that we understand this from different perspectives with different examples. So again, the major premise in this case, maybe I'll scroll back up here to this, and we'll kind of substitute some stuff. The major premise is that social learning says that if people observe aggressive behavior toward a doll, then they are more likely to engage in that aggressive behavior. All right. The minor premise is a woman was using aggressive behavior toward a doll, and then the consequent was that the children were aggressive toward the doll. And then because they also use a control group, the minor premise in that case is that if the children see non-aggressive behavior toward the doll, then the conclusion or the consequent is that they would not engage in aggressive behavior toward the doll. So we can see how that major premise and minor premise line up to form that conclusion. Now, if we think about the implications of social learning theory in this case, which is kind of the big deal, right? It's not enough that we just talk about the nature of the relationship between the if and then statements. It's important that we talk about what it means for real life. So the implications of social learning theory are varied, but a couple of the main points is that people who see media violence may be more likely to subsequently engage in aggressive behavior. There is a theory that, maybe I'm stepping on my own toes. We'll talk about it in a minute. So yeah, I'll just hold on to that. Okay. And then the copycat crimes may be committed by those who hear about violent acts through the media. So there are some implications of this social learning theory that we can look at, and we could make more deductions about that. We could look at more examples of why people engage in aggressive behavior or why copycat crimes were committed. And if they start to say, well, I did it because I saw it, or I did it because I was looking at something on TV, or I wanted to do that same kind of aggression in the way that the person who committed the crime did. Okay, all those things will lead back up to social learning theory. So again, in that way, deductive reasoning is confirmatory. Okay. Now, what's interesting about this is that there is drive theory, and drive theory was popular back in the late 50s, early 60s, and it suggested that venting or fantasizing about some kind of aggressive behavior would somehow allow you to vent that impulse so that you wouldn't enact it. Well, they found that that it could reduce it, but there really wasn't a lot of support for that. And the suggestion was that there was this catharsis moment where if you engage in this behavior, it somehow allow you to express these really deeply held emotional states, and you would feel better by doing it. Another way of doing it is, or another word for it is abreaction. Catharsis and abreaction are kind of the same. It's about experiencing some kind of emotional thing, but catharsis tends to be more unconscious. So you had some kind of release of something you weren't aware of, where abreaction is you had a release of an emotion that you were completely aware of, but you hadn't had a good outlet for it. Okay. If you take counseling and psychotherapy, you'll learn more about that. So that was kind of the theory, but what ends up happening is that the examples that supported drive theory were not good. So what happened was that for social learning theory, if we found that people who were looking at violent video games would actually engage in those aggressive behaviors more than those who did not watch the violent video games. Okay. For drive theory, blowing off steam was not supported by research. And what happens is that anytime you have research that does not support an original theory, there has to be a lot of examples that support that same conclusion, right? We can't just have one study that contradicts a theory. We need to have several of them, and there were others that supported that. So Bushman, Baumeister, and Stack, and then Tavris, all in 1989, suggested that blowing off steam was not great. So drive theory has kind of fallen out of favor for that reason. Okay, so it's important that we use deductive reasoning in order to confirm some kind of theory. And in this case, social learning theory was supported by deductive reasoning, but drive theory was not. So it is important that we go back and test other theories to see if they still hold true. Okay. So now that we've learned about what these things are, fallacies and thinking errors creep into our minds because oftentimes, at the very least, we are unaware of how conditional arguments work, how deductive and inductive reasoning work. And that's the harmless, maybe that's not the right word, but it's the least intentional way of getting it wrong. Lots of times we can flout the rules and we can purposely create some kind of situation where we do something like assert the consequent, or we have a deductive fallacy or something. So let's take a look at what those are and how we can avoid them. Okay. So a deductive fallacy is a type of thinking error. Okay. What happens is that we don't follow the correct logical form. So we know that if we have a deductive reasoning statement, it needs to be if something happens, then another thing happens. Okay, so that's the way that we create the logic. Okay, so what happens is that we can do something called asserting the consequent. We know that we assert the antecedent by suggesting that something happens before something else happens. So if we do that, we've done a good job. If we assert the consequent, then we don't. And we'll get into some examples of how that works. Okay. So let's take a look at the Broca's area issue again for the 100th time. So if the Broca's area is damaged, this is a major premise, then speech production will be impaired. Okay, now let's say that you meet somebody who has speech impairment. If you conclude that he has Broca's area deficiency or that the Broca's area has been damaged, then you would be incorrect. Now, it may be true that that's the case, but you've made that assumption based on the consequent, just by saying, oh, you have something wrong with you, it must be this. That's not how that works. You have to use a better logical flow than that. Okay, so let me give you an example that might make this a lot clearer. Let's start with a major premise, and we'll just kind of go over what that looks like. So a major premise, let's say, is that John goes to the park on Tuesday. So if it is Tuesday, then John will go to the park. Now, if I wanted to have some kind of correct flow, then I would say something like, if it is Tuesday, then John goes to the park. Okay, so it is Tuesday, John is at the park. Okay, that makes sense. But if I said John is at the park, so it must be Tuesday, I'd be flipping that around, because even though we say that John goes to the park on Tuesdays, okay, he can also go to the park on a Saturday, let's say. So if we said John is at the park, therefore it must be Tuesday, that is incorrect. It might be Tuesday, but it could also be any other day of the week, because the only thing that we have said is that John goes to the park on Tuesdays. So if you assume that is Tuesday because he's at the park, you could be wrong. And that's asserting the consequent. It could be any other day. But we do know that if it's Tuesday, then he'll be at the park. So we have to be able to keep that in mind, that the consequent does not dictate what happened before it. Okay? So for example, somebody with some kind of speech impediment or speech impairment could have Broca's area deficiency, or it could be something else altogether, right? But all we know is that if we have Broca's area damage, then it's probably, well, it's likely to lead to some kind of speech impairment. So the antecedent must predict the consequent and not the other way around. No matter what the consequent is, we cannot suggest that it predicts the antecedent because there's a flow that has to be maintained there. What can also happen is that we can shift the burden of proof. And what burden of proof means is that somebody making an argument needs to be able to defend it in some way. Okay, so another way that looks is that you can argue that something doesn't happen or doesn't exist. Okay, so in this example, shifting the burden of truth, we can say that it occurs when one argues against a theory by saying that there is no evidence against a contested theory, so the contested theory must be true. Okay? So flat Earth, let's say that somebody said the Earth is flat, and they said there's no evidence that says it's not flat. Well, okay, there is, by the way, but let's say for the sake of argument that there wasn't any. Just because there isn't any evidence contesting a theory doesn't mean that just because we haven't noticed any evidence against a theory doesn't mean that theory is not true. There are lots of opportunities for us to be wrong about things, and that's fine. So we have to recognize that even though there is no evidence against it, that doesn't mean that it's not true. So let's use an example like the search for extraterrestrial intelligence, right? So we're looking at aliens, and somebody says to me, aliens exist. Okay, fine. They need to prove that. Okay? If they say that no aliens exist, they really don't have to make that proof unless somebody contests it by saying, yes, aliens do exist. Okay? Which is kind of tricky in a case like looking for aliens, because we have, sometimes evidence that's pseudoscientific, a lot of the times it's parapsychological, sometimes for aliens, or it's circumstantial or something. And the tricky part is the burden of proof. So who is responsible for finding these aliens if somebody says that they do exist? And one of the things that's tricky about this is that when somebody says something like, yes, aliens do exist, and I say, well, they don't, and the person has to prove that they do. What we go into is a lot of argument about, well, what's the likelihood of aliens existing, and there are formulas for that. There are people who come up with formulas for the likelihood of there being intelligent life somewhere, et cetera, et cetera. But even though there are theories about whether or not there is intelligent life forms, there hasn't been any hard scientific evidence for it. Now, what is interesting, though, is that we say something like, well, there are no aliens out there, and we say, well, based on what? Well, based on our observations. Okay, the burden of proof is on them to maintain that kind of, well, I'm not sure if there are any aliens type of mentality. But we also have to consider something about the amount of observations we have made so far about the known universe. And one of the examples that I've heard is that if you took all the water in all the oceans and somebody took a water glass and dipped it in the ocean and looked inside and said, look, there aren't any fish in the ocean, that would be about the same as making a claim about whether or not there are aliens in the known universe. So what that means is that we have explored the same amount of space as somebody who dips their drinking glass into the ocean and makes a claim about what they see. So when we talk about burden of proof, there are certain circumstances where it's difficult to prove something, but the burden of proof is still on the person who is making the contestation of a theory. Okay. So the reality is that the person supporting the claim has to back up the claim or defend the claim. The same thing as if you contest a claim. You have to make a reasonable contestation to it. You can't just say, no, you're wrong. You have to say, no, you're wrong because. But again, the initial burden of proof is on the person who is making the claim. Even if they're claiming that nothing is happening, they have to give reasonable evidence that suggests that nothing is happening. Another example of this. So creationists argue that scientists have not proved that creationist science is not true. Therefore, it is likely true because otherwise we would have shown it to be false. So what happens here is that people who believe in creationism have suggested that, well, no one's proven it false, so it must be true. That's not quite how that works. You must prove that something is true in order to make the claim. Okay? So the burden of proof is on creationists to support their view and not for somebody else to prove it wrong. Okay? And then the last logical fallacy that we're going to talk about is circular reasoning. It's when you form a conclusion of an argument and it's based as the premise of the argument. So an example is that the news is fake because so much of the news is fake. Okay? You know, obviously that does sound true. It's circular. You're defending an argument with itself. Okay? So people will oftentimes try to do this by saying something like, the President of the United States is a good leader because he's led the country well. Okay, that doesn't really give any evidence for it. If you provide evidence and say why he's been a good leader, that's fine. But when you just say that something is a certain way because it is a certain way, that's not a good argument. That's not conditional. It doesn't help anybody. It's just circular. Then the last thing we'll talk about today is making assumptions and arguing from a perspective. An assumption is some kind of unstated premise that is taken for granted in an argument. Okay, so an assumption can be a part of an argument, but it's not always backed up by a lot of support. Okay? So, for example, if someone is nice to other people, then that person will be liked. Taylor is liked by many people, so the assumption is that they're a nice person. Okay? Now that may be true that they're a nice person, but what you're suggesting is that the consequent has been asserted. Remember, we just learned that we don't assert the consequent because we cannot know if there is a conditional relationship in the opposite direction. It needs to be if then, not then if. Okay? So what happens is that we can say, well, Taylor is nice, and that's why people like that person. So we have to have some kind of antecedent in place. So if someone is liked by many people, you cannot assume that they're nice. There could be other reasons why somebody is liked by many. Maybe they have lots of money. Maybe they're handsome or good looking. Whatever it is, that's why people like them. Maybe they're funny. Who knows? But we have to assume that just because we have some kind of major premise like people who are liked are nice, right? So if you're nice, then people will like you. We have to make sure that that whole condition is present in order for us to make an assumption. So just to say that Taylor is liked by many people, so Taylor must be nice, that's inappropriate because, again, we can be liked for other reasons, not because we're nice. So we have to be careful of what we assume based on what we believe to be true about the world or the nature of niceness and people being liked. Okay, so when an assumption is unwarranted, that means that the assumption that we're making is not supported by reason. It doesn't make sense. It's something that somebody is making up just to prove a point. Okay. You can oftentimes lead to a wrong conclusion. Usually unwarranted assumptions are about people's motivations for doing something. So why did somebody do something? Like, I don't know, maybe ... And if that's the case, then you are making an unwarranted assumption about the relationship between that person and the conclusion that you are trying to draw based on the argument. Okay. So what happens when we have unwarranted assumptions is usually that we're missing a premise. We're missing something that's part of the if part of the statement. Okay. So we need to look for evidence that supports our assumptions. If we can't find it, we need to drop our assumption. Or we need to research it more and to figure out if our assumption is correct. You don't lose anything in life by dropping assumptions. Assumptions don't help anything. No, once you have created evidence for your assumption, then you have a good argument, right? It no longer becomes an assumption. It becomes something that is based on some kind of evidence. Remember, the nature of an assumption is that it lacks evidence. and we want to make sure that we have evidence or support for the arguments that we're making. Now, what also happens is that psychologists or anybody in life can make assumptions when they argue from a perspective. Okay, so what this means is that people who have different theoretical backgrounds assume certain things about the world. As a matter of fact, when you're developing a research plan, some of the things that you will do is list the assumptions that you have about the nature of the data that you're collecting, whether it's qualitative or quantitative. And that's based on the perspective that you have. So here's an example. So cognitive psychologists assume that people process information in some ways similar to how a computer processes information. Okay. Social psychologists assume that behavior and expectations of other people influence an individual's own behavior. Okay. So these are perspectives that these two types of disciplines have, and they would explain how people process information differently. So cognitive psychologists think that people process information like a computer might by storing it and accessing it and creating networks and things. Social psychologists might say that people process information based on what others expect from them and the influence that they have in the relationship to the environment around them. So this is all about the perspective. So we make assumptions about things. And the last thing we'll look at here is just a quick table of the thinking errors and argumentation errors. And again, these are available to you in your textbook. That's table 2.3 in chapter 2. All right, I know there was a lot there, and you're probably sick of hearing about if-then statements, and you may feel like you've heard way too much about it, but it's important for us to cover this information so that we can be at least aware of how to make deductive reasoning statements and to avoid the errors that come alongside of it. Really, if you can remember to think about a major premise, the support for what you're thinking, and then use deductive reasoning to find specific examples to support it, and make sure that you are supporting your conclusion with evidence, you'll be in good shape. Okay. And again, you don't have to always think about this in every manner of life, but when you're thinking about psychology, when you're thinking about the way that you can engage in research, it's important to think about deductive reasoning.